start recording at the beginning of class. So this is what we were looking at. We were in the middle of, well, we were just about to start question 5 yesterday when the bell went 4 minutes earlier than I was expecting it to. I only want to do as many of these as you guys would actually think is useful. At some point, I'm happy to just let you go and start playing with stuff. So yeah, like I said, I'll do as many or as few of these as you guys think is useful. If at any point you feel like, you know what, no, I can handle this, by all means, we are going to skip this part C, the relationships between variables. We are not doing this. We will skip this. And you are welcome at your leisure. You're like, yeah, I got a handle on this stuff. Feel free to jump over to this Math Review Formulas page. I will be assigning all of it here momentarily for you guys to spend some time playing with it. How many of you guys would still like me to do a couple more of these examples? Again, I only want to use the time if you would find it useful. Hands up if you're like, yeah, do a couple more. Okay, cool. If you're not interested in that, by all means, flip the page and you can start working on this stuff on your own. Okay, so rearranging formulas. If you were away yesterday, I started by just substituting values into formulas and then solving for a variable. Students typically find this to be easier, just because with the numbers there, life does seem to get a little bit nicer. When we are just dealing with letters and moving them around, students, for whatever reason, seem to get more uncomfortable with this. So again, this is where I'm at looking at examples. So if you take a look at 5, I want to solve this thing for p. Now there is no big P here, so let's fix this. That should be a lowercase p, because that's the p we're solving for there. And this is the equation that we're looking at. So I've got mf equals 7d minus 3p plus 8x. Unlike everything that came before it, this is not a formula for anything. It's just a random string of algebra. The only difference, and this was said yesterday, the only difference between this question and the ones that came before it is that none of these have any addition or subtraction in them. So if you recall back to grade, I want to say grade 9, because there's addition and subtraction in here now, those are what separate out terms. So I've got 3 terms here, and I want to solve for p. When you've got an expression like this, the first thing we want to do is, what do you think? What do you remember? If I want to isolate p, there is a first thing to do. It is not division. Yeah, Lena.
Subtract the 7d and our 8.
Yeah, we won't, because we're adding, well, the 7d is positive, and the 8x is positive, so these two guys are being added in here. Remember, when we're isolating, we're working BEDMAS backwards. So we want to deal with any addition and subtraction first, and then move our way to dealing with the division and multiplication. So I want to, the term for this is isolating this term. I want to isolate that. Isolate this term. And I'm actually going to move over here to do that. So I'm going to rewrite this over here. I've got mf equals 7d minus 3p plus 8x. And I want to isolate this. So 7d and 8x are both positive, so I'm going to subtract them both over. I'm going to subtract 7d, and I'm going to subtract 8x from both sides. And I'm going to get mf minus 7d minus 8x. That cancels and that cancels. Is going to equal whatever I have left over here, including whatever sign is out in front of it. So that negative, or that subtraction there needs to stay as a negative on the 3p. So we're going to get negative 3p in here. And then my last step to get p by itself. Now this is when we're going to deal with any multiplication or division. Yeah, Lena? Yeah, we're going to divide this by negative 3 and this entire side by negative 3. This is going to cancel because negative 3 divided by negative 3 is 1. And so p, I'm not going to rewrite it, p is just going to be equal to this whole thing, mf minus 7d minus 8x, all divided by negative 3. And we're done. There's nothing else we have to do there to deal with that. We want to deal with the extra terms, and then we want to deal with any multiplication or division. Don't worry, I got lots of chance to practice this in a sec. Okay, next one, this is a simpler one again. There's only one term. It's d over t on this side and v on this side. And I want to solve this thing for d. So what do I have to do, Lena? Yeah, we're dividing d by t. So to get d by itself, we want to do the opposite of whatever's happening to it. So I'm going to multiply t on both sides. Here they're going to cancel. And on this one I've got space, so I'm going to rewrite it. D is going to equal, and I'm actually going to write it in this order, v times t. Because if you saw it in grade 9, that's probably the order you're used to seeing it in, or grade 10, or wherever you saw it before. And if you haven't seen it before, this is the form we're going to use it in. So that's the way I want to write that. Because you can multiply in any order, right? You could write it as t times v, or v times t. And then we got these last two are kind of on the nastier side. Because this one's got multiple terms again, and this one's got terms buried in the numerator of a fraction all multiplied by something. So this one's going to be a fun one too. So let's take a look at these last two. Someone other than Lena. Who's got a good idea or a thought about where we could start 7 given what we did with number 5? Yeah, Vine.
Minus VIT.
Yeah, we're going to take away this whole term here. We want to isolate whatever term includes the a, so we want to leave this guy alone. We're going to subtract rather this VIT over. So I'm going to minus VIT on both sides, minus VIT. Here they're going to cancel. And so what we're going to get is D minus VIT equals 1/2 AT squared. And A is one I want to get alone. So there's a few ways that you can play with this at this stage. Who's got a thought about where we could go from here? Yeah, man, here today. Okay, we can multiply 2 on both sides to get rid of the half. Timesing by 2, timesing by 2. This is where you're going to want to be real careful. I see this mistake with my 9s and 10s all the time. When I multiply this side by 2, I need to make sure I multiply this whole side by 2. And we do that by throwing brackets around whatever's there and multiplying the whole thing by 2. Here, these are going to cancel. Now, if you want, when you multiply this whole side by 2, you can distribute this 2 in. You can multiply it onto the d, and you can multiply it onto the negative VIT, but you don't have to. If all you're doing is solving for a, you can leave it like this. I'm going to rewrite it over here. You can leave it as 2 bracket d minus VIT, and that's going to equal AT squared. You can leave it looking like this without distributing this in. And then we've got one more step. Lena, you look perturbed. Do you want me to? Okay. In a second, you did it already? Like you've done the whole thing already?
Yeah.
Okay, I want to see what yours looks like and how it's different than what mine is going to look like. Last step here to get a by itself, what do we got to do? Yeah, here, Dave? We're going to divide by t squared. We're multiplying a and t squared together because there's nothing written in here. That's what's going on. So I'm going to divide this by t squared, and I'm going to divide this whole thing by t squared as well. So that's going to cancel. And the way I've done it, a is going to equal 2 bracket d minus VIT all over t squared. Now, Lena, what did you get?
I divided by a half.
A half t squared all in one shot. So your result looks like this. A equals d minus VIT all over 1/2 t squared. Okay, that is equivalent. Because when we divide by a fraction, that's the same as multiplying by the reciprocal. So you'd multiply this thing by 2 over 1, it would get multiplied into the numerator, and you'd end up with this. That's fine. You can leave it like this or like this. Both are entirely acceptable. I don't care which one. I'm not going to call one right and one wrong. You could, if you wanted to, distribute this thing in here. There are ways that we could make this thing cleaner. I'm not going to tell you you have to do it this way, but I want to show you another way this thing can be written. I'm going to multiply this thing in. So we're going to go this way. And I'm going to get 2d, distribute them in. I'm going to get 2d minus 2vit all over t squared equals a. And then there's another simplification we can actually make here. When you have multiple terms all divided by the same thing, you can rewrite it as this term over this and this term over this. So we can make another simplification here. We can write this thing as 2d over t squared minus 2vit over t squared equals a. And then there's another simplification I can make here. When I've got t divided by t squared, your exponent laws are going to tell you that this t and that squared are going to end up canceling. Or I've got t to the 1 and t squared down here, so 1 minus 2 is negative 1. Ultimately, what's going to happen is that t is going to cancel out that exponent, and we're going to be left with 2d over t squared minus 2vi over t equals a. And believe it or not, all of these expressions, this one here in blue, this one here in blue, and this one here in red are all equal. And at the end of the day, I don't care where you choose to leave yours as long as you've got something equivalent to one of these three. Questions, comments, concerns about what I've just done? If it's too early on a Tuesday morning, you're like, I have no idea what the heck just happened, I'm happy to explain it to you a little bit more when you're feeling a little bit more like you can handle it or more awake. Otherwise, as long as you're comfortable with one of these two, I don't need you to see the red at all. Okay? And then the last one is something like this. These are always going to be the worst kinds of things because we've got a variable buried within the numerator of a fraction inside some brackets. Like it's just really far in there. But again, not something that, I mean, this might be the furthest stretch on something I ask you to do, but not something that's outside skills you already have. Regardless of what math class you took last year, you've got the skill set for this. So there's a few first options here. Does anyone want to suggest a first move? It's the same two every time. Someone other than Lena or Hirde. Or I'll just, yeah. You want to divide this thing by t? Sure, that is a totally acceptable first option. Because I'm multiplying this whole set of brackets by t, we can divide that t out. Come on, I'm losing orange. Use a different orange. That orange is failing too. Okay, the t's are going to cancel here and here, and we're going to be left with d over t equals vf plus vi all over 2. That was not the only first option. I could have, if you want to deal with it this way, I could have distributed that t in there. If that makes you more comfortable, that's an acceptable first option as well, but this is cool too. If this is the path we're going to take, what's the next step have to be? There is only one next option here. Yeah, keep going. Careful. Yeah, we want to multiply by 2. It's being divided by 2, so I want to get rid of what's dividing this whole piece. So I'm going to multiply both sides by 2. Here my 2's are going to cancel, and we're going to get vf plus vi equals 2d over t. And then our last step is nice and easy. I've got two terms there that are added together. To isolate for vf, I'm going to, subtract vi. on both sides. And so what we're going to get is 2d over t minus vi equals vf. Now, that's not the only way to do it. You could have distributed that t in first. If you had distributed that t in first, what you'd get, I'll show you what the final result would have been if we distribute t first. Distribute t. If that had been the route we would have taken, what we would have ended up with was 2d minus vit all over t equals vf. So I don't know if you did it a different way. These are the two expressions. These are two equivalent expressions, and these are the two ways to go. Yeah, Adafa. Because this is buried inside a bunch of other stuff, you can't, like, if I wanted to subtract that vi, I would have to rewrite this thing by rewriting it as vf over 2 plus vi over 2, and then I'd have to distribute that t in there, so I'd get vft over 2 plus vit over 2, and then I would subtract that term out. When you've got things multiplied on there, you can't just go in there and pluck out a single term. The brackets, unfortunately, make that impossible for us. And again, if you follow this, if this is the way you're going about it in your head, looking at what we have here, when you've got multiple terms inside a numerator, it's like they're inside a set of brackets. And so if you follow this, you're not actually starting with the addition and subtraction. Because they're tied together inside a numerator, they're actually in the bracket portion of BEDMAS. So you're going to have to start with the multiplication and division on something like this before you can deal with what's going on inside those brackets. Does that make sense? Yeah. Okay. If you want to see this in more detail, or if you want to give this a shot on your own, that's great. Do that. But this is it as far as the practice on, or the examples for rearranging these formulas. And I think the best use of time now is for you guys to go play with these things on your own. So I want you to flip the page. We're going to skip, like I said already, skip part C here. And I want you to deal with this page here. I want you to do all of it. There is one teeny tiny one thing I have to explain for those of you who haven't taken chemistry yet. This formula down here, this is in question 5 on the bottom. This guy here, that's the Greek letter rho. So rho equals m over big V. I just want to explain what these things are because the wording of the question doesn't tell you what they are. This right here, that symbol rho, is density. M is mass. And big V is volume. And so that question actually gives you the volume of the can, the density of the aluminum, and some density of mercury. So it wants you to use this formula to find the mass of that volume of aluminum and that volume, where is it? This volume of aluminum and this volume of mercury, given their different densities. There's 2 questions there in question 5 there. So play with this, see what you can. Don't, by all means, please don't cram it all onto this page. I want you all to have line paper, whether that's in a coil book or whether it's in your binder. Do that work there. Don't treat that work like scrap paper. Number the questions. Put a title at the top so you can go back and reference this thing again. Get into the habit of organizing your work to make it something that you can actually go back and reference when you're studying for this test. So take a look at this page here. We'll see where we're at in about a half hour. If I can, I'd like to start trigonometry today, but I'll play that one by ear. Okay? On your market set, giver. Take a look at these. I'll unpause this. Okay, I want to remind you guys of how you deal with fractions and things buried in denominators. When you've got something that looks like this, and I want something that's located in a denominator, there's a few ways you can handle this. One of the things you can do is get rid of those denominators by multiplying everything by a common denominator. That's one of your possible techniques. Another technique is just to isolate the fraction that includes your variable in the denominator, and then treat this as one object. If I want to get s by itself and it's stuck in a denominator, I have to get it up out of there. So I have to multiply s on both sides. Here it's going to cancel, and over here I'm going to get s times 1 over big R minus 1 over little r equals 1, because that's all that's left over here. And then because I have s times this equals 1, to get s by itself, I'm just going to divide by this entire object right here. On both sides. It's going to look ugly, but it's mathematically correct. And at the end of it all, you're going to get s equals 1 over this whole mathematical object. And that is a totally acceptable way to leave a question like B. Question F is similar in its first step. Because what we've got is buried in that denominator there, multiply both sides by this entire denominator. And go from there. Yeah. Say that again.
Right, you know, we see we got fraction of the denominator, right?
Yeah.
How we just, so it's just so like fraction of the denominator, dividing the denominator, the fraction is like multiplying this and this.
Because they're being added and subtracted to each other, we can't just jump straight to that. I would have to combine these into one fraction and then multiply it by the reciprocal. You could do that by making these a common denominator. You get little r over big R little r minus big R over big R little r. Then you can combine those fractions because they have the same denominator. And then you could take that one step further and flip that fraction. You could do that. You get something, you get this. You get, see if I can do it in my head. You get big R over little r all over little r minus big R. You could do that, and this is what you get, but this is a totally acceptable place to stop. Just dividing this entire object down is a totally acceptable place to stop. Now, given what I did here, I do want you to try F. I'm not going to do that one yet. Are there any other questions you want me to do before I get you going again?
Just a question. Wouldn't it be s equals negative? In the equation, it's negative 1 over s.
Oh, yes. Yes. I dropped a minus sign. Thanks, Vian. Which means we could take this one step further and do this. Big R over little r over r, big R minus little r. I can do that. But again, you can leave this here. Yeah? 2c? Yeah, because e is in the numerator, just being multiplied there by that n, to get it by itself, all you'd have to do is multiply that whole denominator up and then divide this n over. So if I multiply this whole thing up, I'm going to do a different color so it doesn't get mushed in with the top bit. Multiply both sides by nr plus r, and you're going to get c bracket nr plus big R equals little n times e. You can treat that whole denominator as one mathematical object and multiply the whole thing up. And then the last step here I think is fairly straightforward. Does that make sense? Okay. Yeah, man.
RNC.
Oh, okay, you can't split. Okay, I'm gonna pause this again and you guys can get back to what you're working on. I'll deal with individual questions.